If you walk into a professional kitchen or a high-end home today, you are looking at a battle between two completely different centuries of technology. On one side, you have gas. It is primal. It is visual. It is the taming of fire to cook our food, a tradition that goes back to the dawn of humanity, just modernized into neat blue rings. It's what professional chefs have sworn by for decades. On the other side, you have induction. It's silent. It's sterile. It's a sheet of black glass that looks like it belongs in a spaceship rather than a kitchen. It doesn't use fire. It doesn't even use a heating element. It uses high-frequency electromagnetism to turn your cookware into the heat source itself. The debate between these two is no longer just about which one cooks better. It has turned into a war of physics, efficiency, and even indoor air chemistry. One of these technologies is a master of convection and radiation, while the other is a master of electromagnetic induction. Today, we are going to look under the hood. We're going to talk about why gas stoves are technically heating the universe more than your soup, and why induction might be the most precise tool ever invented for a kitchen, but also why it might require you to rethink everything you know about cooking. I'm Sal, and today we're breaking down the physics of gas versus induction. To understand why gas is the way it is, we have to look at the chemistry of combustion. When you turn that knob and hear the click-click of the igniter, you are releasing natural gas, which is mostly methane or propane. When that gas meets a spark in the presence of oxygen, a chemical reaction occurs. In scientific terms, one molecule of methane combines with two molecules of oxygen to produce carbon dioxide, water vapor, and a massive burst of energy, which we see as heat. This is an exothermic reaction. The energy stored in the chemical bonds of the gas is released as heat and light. That beautiful blue flame is a sign of complete combustion, where the gas is burning at its most efficient temperature, roughly 1,980 degrees Celsius, or nearly 3,600 degrees Fahrenheit. But here is the catch. The flame is not the heat source for your food. In a gas setup, the flame heats the air, and that hot air rises. This is convection. The hot air and the infrared radiation from the flame hit the bottom of your pan. The pan then transfers that heat to your food through conduction. The efficiency problem. Because gas relies on heating the air to heat the pot, it is inherently leaky. If you've ever stood in front of a gas stove on a hot summer day, you know exactly where that extra energy is going. It's going into your face, your cabinets, and your kitchen's ambient temperature. In the world of thermodynamics, gas is a broadcast system. It's shouting heat in every direction, hoping the pan catches some of it. Now, let's look at the magic trick of the kitchen. Induction doesn't use a chemical reaction. It doesn't even use electrical resistance like a traditional electric stove. Underneath that ceramic glass sits a tightly wound coil of copper. When you turn it on, the stove sends an alternating current through that coil. But this isn't the slow 50 or 60 hertz current coming out of your wall. The stove uses an inverter to ramp that up to a high-frequency current, somewhere between 20,000 and 50,000 cycles per second. This creates a rapidly oscillating magnetic field. If you put a glass pot or an aluminum pan on there, the magnetic field passes right through them like they aren't even there. But if you put a ferromagnetic pan, like cast iron or stainless steel, on the surface, the physics gets aggressive. First, we have eddy currents. The shifting magnetic field drags the electrons in the metal of the pan back and forth. Because the metal has electrical resistance, this movement creates friction at a molecular level. This friction turns into heat inside the metal of the pan itself. Second, we have magnetic hysteresis. The tiny magnetic domains inside the iron are being forced to flip their polarity 50,000 times a second. Imagine trying to turn a doorknob back and forth that fast. It's going to get hot. The result? The stove is not a heater. The stove is an energy transmitter. It sends energy through the glass via a field, and the pan converts that energy into heat. This is the ultimate middleman elimination. In physics, we look at energy transfer efficiency. If you pay for 100 units of energy, how many of those units actually end up in your pasta water? Gas stoves. On average, gas stoves are only 35 to 40% efficient. This means, for every dollar you spend on gas, 60 cents is literally vanishing into the air of your kitchen. It's why professional kitchens require massive, expensive ventilation systems. They aren't just clearing smoke, they are clearing the massive amount of wasted heat. Induction stoves. These units are typically 85 to 90% efficient. Because the heat is generated in the pan, there is almost no ambient heat loss. The only heat lost is a tiny bit of radiation from the sides of the pot. The speed test. If you want to boil a large pot of water, gas will take about 8 to 10 minutes. Induction will take about 4 minutes. Induction is so fast that it actually catches people off guard. If you are used to gas, you might put a pan on the flame, go to the fridge to get butter, and by the time you come back, your pan is already smoking. It's the difference between a freight train and a Tesla. This is where the debate gets heated. Ask any professional chef why they love gas, and they will say, responsiveness. With gas, the control is visual. You turn the knob, the flame gets smaller, and the heat input drops instantly. You can see exactly how much energy you are applying. Gas also allows for off-the-pan cooking. If you lift a pan to toss a stir-fry, the flame is still there, licking the sides of the metal, keeping it hot even when it's not touching the grate. Induction's precision. Induction is even more responsive than gas, but in a different way. Since there is no thermal mass, meaning no hot grates and no hot air, when you turn the power down, the heat generation in the pan stops immediately. But induction offers something gas never can: low temperature stability. Try to melt a single square of chocolate directly in a pan on a gas stove. Even at the lowest setting, the flame is often too hot and you'll burn the chocolate unless you use a double boiler. Induction can be set to a wattage so low that you can melt chocolate for hours without it ever seizing. It can hold a simmer at exactly 82 degrees Celsius or 180 degrees Fahrenheit indefinitely. However, induction has a weakness: the flick. When you lift a pan off an induction surface to toss your food, the magnetic connection is broken. Most induction stoves will start searching for the pan, and might even shut off if it's away for more than a second. For chefs who like to move their pans constantly, this feels clinical and restrictive. We have to address the pot problem. Gas is the universal donor. It does not care what your pot is made of. Clay pots? Works perfectly. Glass pots? No problem. Cheap aluminum pans? Absolutely. Warped, dented old pans? Gas doesn't care. The heat will find a way. Induction is the exclusive club. It is a technology that demands a specific handshake between the stove and the pot. If the pot isn't magnetic, the stove won't even turn on. This means your expensive copper pans or your traditional ceramic cookware are useless on an induction cooktop. The magnet test. If you're thinking of switching to induction, take a magnet to your cupboard. If it sticks to the bottom of the pan, you're good. If it doesn't, you're looking at a $500 to $1,000 investment in new cookware just to use your new stove. In recent years, the conversation has shifted from how it cooks to how it affects your health. This is where the physics of indoor air quality comes in. The gas problem. Remember that chemical equation? In a perfect world, gas burns into carbon dioxide and water. But our world isn't perfect. Small amounts of nitrogen dioxide, carbon monoxide, and formaldehyde are often released during gas cooking. Nitrogen dioxide is a respiratory irritant. Studies have shown that in homes with poor ventilation, gas stoves can raise indoor levels higher than what would be legal outdoors. Furthermore, even when turned off, gas stoves can leak small amounts of methane, which is a potent greenhouse gas. The induction solution. Induction has zero emissions. There is no combustion. There is no gas line to leak. Then there is the safety of touch. On a gas stove, the iron grates stay dangerously hot for 15 to 20 minutes after you finish cooking. On an induction stove, the glass only gets hot because the pan was sitting on it. The moment you move the pan, the glass begins to cool. You can literally boil water on an induction stove, move the pot, and put your hand on the glass 30 seconds later without getting a third-degree burn, though it will still be uncomfortably warm. I can't finish this comparison without talking about Wok Hei, the breath of the wok. In Cantonese cooking, the flavor comes from the singeing of the food as it passes through the column of intense heat above a high-pressure gas burner. This involves the Leiden-Frost effect and the flash vaporization of oils. Induction struggles here. Because the heat is only generated where the pan touches the flat glass, you don't get that wall of heat rising up the sides of a curved wok. While there are special concave induction burners made specifically for woks, a standard flat induction cooktop will never truly replicate the experience of stir-frying over a roaring flame. Finally, we have to talk about your house. Gas requires a gas line. If you don't have one, installing one is expensive and sometimes impossible. Induction requires a massive amount of electricity. Most induction cooktops require a dedicated 40 or 50 amp circuit. This is the same amount of power your central air conditioner uses. If your kitchen isn't wired for high-voltage electric cooking, you might need an electrician to upgrade your breaker panel. The cost: induction stoves have come down in price, but they are still generally 20 to 50% more expensive than an equivalent gas stove. However, you have to factor in the efficiency tax on your monthly bills. So, which one should you choose? Choose gas if you are a traditionalist who loves the feel of fire, you use round-bottom woks or clay pots, and you want your stove to work even during a power outage. Choose induction if you want the fastest, most efficient kitchen possible. You hate cleaning, since food doesn't burn onto the cool glass. Or you live in a hot climate and don't want your stove to turn your kitchen into a sauna. At the end of the day, gas is the technology of the industrial age, robust, hot, and slightly messy. Induction is the technology of the information age, precise, efficient, and digital. Personally, I think the physics of magnets is just too cool to ignore. The ability to boil water in 2 minutes and then wipe the stove clean with a single swipe feels like living in the future. I'm Sal, and now you know exactly what's happening when you turn that knob.